Hi again. This is for uh, the MN inventory policies. So here we are going to have the simulation model for the refrigerator example. So at first we have the data of the problem. So the demand will be 0, 1, 2, 3, or 4 units each day. So we have the probabilities, we have the CDF function here, and same for the lead time. Lead time could be 1 day, 2 days, or 3 days. Again, we have the probabilities, we have the CDF here, and these are the problem assumption. The number of cycles that we are going to simulate is 5. So we'll have 5 cycles of 5 days. So in total, 25 days. Okay, and the maximum inventory level of inventory could be 11, and the number of days at each cycle is 5 days. So we're going to actually order every 5 days. We will have an order. So, and ending inventory, I mean, now time is 0. So actually we are processing a previous cycle, right? So here we assume that the ending inventory left in the warehouse from the previous cycle and will be available at the beginning of the first day of this cycle is 3. Okay, and we assume that we have placed an order at the end of the previous cycle, I mean on the 5th day of the previous cycle, and we assume that its size is 8 units, and the lead time for that order is 2 days. Okay, so these are our assumptions. I mean the initial setting actually for the system. Okay, so we are going to actually simulate the system for 25 days, 5 cycles, and each cycle includes 5 days. So yeah, for day 0, we can actually have the initial setting in day 0, which is actually the end of the 5th day of the previous cycle. Okay, so as you see here, the day within the cycle is 5, so that's the 5th day of the previous cycle. There is no beginning inventory for this day because we assume that we are at the end of the day. Okay, and the ending inventory is assumed to be 3 here. There is no shortage by the assumption of the problem, and there is a pending order. The order size is 8. Okay, and the lead time of this order is 2, and the remaining days on lead time is again 2, is still 2, right? So let's start the first cycle. This is the first day of the first cycle, so day 1, the cycle will be 1 here, and days within the cycle again is 1. So the beginning inventory, by the definition that we had in the lecture notes, it will be G, we are in the row of 13, right? So G12 will be the ending inventory of the previous day, which is the last day of the previous cycle. So it's 3. So it will be 3 plus. If K11, you are in 13 and you're checking the K11 2 days ago for the remaining days on lead time. If you remember in the lecture note, we had that the formula for this quantity, and over there we are assuming that for I, we are having the LC of I minus 2 days ago, right? So this is why here we have K11. So if it equals 1, this means we will have a receiving order at the end of the previous day. So this day, at the beginning of this day, we will have that order in the stock. So in that case, we need to add that quantity to the ending inventory of the previous day, which is I11. I11 is the pending order, right? Or if it's not not equal to 1, then it will be 0. There will be no adding to the ending inventory of the previous day. Okay, so yeah, that's how we implemented that equation here in Excel. And for the demand, again, we generate a random variable from the disk distribution that we have for demand. And so yeah, here we have the beginning inventory as 3. We have the demand for this day as 2. So the ending inventory will be just 1, right? Yeah. And the shortage, there's no shortage here. So you see the relations. These are exactly based on the definition that we have on the lecture note. Okay. And again, for pending order at this time, as you see here, there is still 8 units of refrigerator as pending order on the way, and the remaining days on the lead time is 1 day. It was 2 days previously, but we have passed 1 day, so it's reduced to 1 day, right? So yeah, as you see here, we have actually the result here for 20 days and average ending inventory. These are actually our measures: average ending inventory, total shortage, and average demand, right? These 3 numbers are the average for the 25 days. So if you replicate this simulation for, let's say, 500 times, then the results will be more stable and more reliable. And as you see here again, we have the 500 applications, and we have average over 500 applications of 25 days. So the average ending inventory becomes this number, 2.9. The average total shortage is 15.6, and average demand is 1.9, less than 2 units of refrigerator per day. Okay, so yeah, this is our simulation for the MN inventory policy. Again, as you see here, we assume that M is given. I mean, the maximum level of inventory here, we assume that it's 11, and the period for reviewing the inventory and placing order here, we assume that it's 5. I mean, every 5 days we are going to place an order, right? So we can change these values, right? We can increase M or decrease M. We can increase or decrease N, and we'll see what's the impact on our performance measures. And by doing so, we can somehow optimize our decision for M and N. Okay, and that's it. Okay, so the last part will be for the reliability model. Okay, thank you.